Okay. So the today agenda is to understand this basics of the, but I'll go with the, maybe this session will go a little bit longer, little bit, not much. So that first we'll understand, I'll give a plot that what ML exactly, what we try to achieve, and according to the data, how we can decide that which algorithm should apply on what kind of data. So for that, we need to understand a few things. So the first meaning this machine learning, what does it exactly means? Just understand it as an one black box in which we will just give some input data. We will give some input data and we will get the result, output data, output data or result. Now, what will be this input data? What will be this output data and result? Let us understand. Let's take a very simple example. Suppose this is any data for an house which has some different areas in square feet. Okay, a square feet area and the price according to that. Okay, and we have many record. Let's suppose this is for an any real estate company or the constructions company data. Okay, now if any house has something 200 square feet, 700 square feet, something 645 square feet, something 900 square feet, something 1200 square feet, or something 1100 square feet, and I'm just putting a random prices something. So let's suppose this is 5 lakh, so price in lakhs. Okay, so something here 5 lakhs, here it is, let's suppose 7 lakhs, this is 6.5 lakh, this is let's suppose 10 lakh, this is something 13 lakh, and this is 14 lakh. Randomly I took for the areas square feet and their prices. So I think we all know the basics on a graph, how we plot the coordinates. So if we will just see this, if we will just see this, this is the x-axis and this is the y-axis. So now here, what will be our requirement? So we will use the machine learnings. What is our requirement? So first we need to understand the requirement. Let us suppose now we have a requirement of house having the square feet of 627 square feet, and someone wants to know the price of that. So now in our data, we do not have any 627 square feet. We have 645, we have 700, we have 200, 900, 1200, 1100, but we do not have the 627. But I want to know the price of the 627 square feet house. How would we do that? So for that, we need to formulate something. We need to perform something and we have to change the data in such a manner so that I can get any of the square feet area from this 200 to 1200, or even more than that also we can get. So now let's understand. So whatever we have to predict, or whatever result we want, or whatever output we want, that should be on the y-axis. That should be on the y-axis. What does it mean? So here, one second. So here, what we want to predict? Price. So the price will be on the y-axis. So let me put it with some different color. So here, price. Whatever we want to predict. So what we want that input will be 627 square feet, and this I want a output. So this is what price. So the price will be on the y-axis, and here area. This is whatever input we will give, that will be on the x-axis. So here now the two terminologies we need to. So slowly we need to understand the terminology one by one. So one by one we'll understand the terminologies. So here the two terminologies we need to understand. The first is dependent variable, and I will request everyone who is starting this as a machine learning, you can ask your question so that I will understand that what you are not able to get. Accordingly, I'll prepare a class or I'll try to solve it here. I'll try to answer it here. So one is dependent variable and another is independent variable. Here few people are few people are who know well these algorithms. So I'm not saying for those, but there are not many people who doesn't know. So for them, so you can ask it your question whatever you want, whatever silly it could be. Don't be shy. So here the two terminologies, dependent variable and the independent variable. Now what is dependent variable? So the dependent variable is that, let us suppose here I'm changing this value square feet. Accordingly, this price is getting changed. Means this price is depending on what? This square feet area. So this is called your dependent. So on y-axis, you will have always your dependent column, means your target column. So these are the names people use to say in this machine learning or the AI industry, or dependent feature, target feature, they will say, or the y feature, like that they will say. And the independent, which is, I mean, by the name it is clear. I mean, there is a no dependency on those columns, means there is a no dependency on this area. So here, let me plot this. So some value. So let's suppose here this is 200 and here I'm just giving 1200. Okay. And here the prices is from the 5 lakh to the prices here 13 lakh. So let me draw it separately somewhere, a little bit bigger. So here now your y-axis is price and x-axis is your area in square feet. Area square feet. This is the x-axis and this is the y-axis. This is the your independent and y-axis is the dependent. So according to the values, so what are the values we need to plot? From 200 to 1200. So I'm just giving some value randomly. So here let's suppose this is 200 and this is here 1200. And what is the x-axis, from where it will start to where it will go? 5 lakhs to 14 lakhs. So let us suppose this is here 5 lakhs and this is here 14 lakhs. 14 lakh, this one. Now randomly I'll plot the points. Okay, I will not go so precise for the points. Okay, now let's understand this the point. Let me little bit zoom out. So for the 200, definitely it will be somewhere here, like 5 lakh it is. Okay, so somewhere here for the after the 200 there will be 645. So 645 will be, let's suppose 6.5. So somewhere here. Okay, and then for the 7 lakh it will be 700. It will be for the 7 lakh. So let it be here somewhere. Okay, let me make it a little bit bigger so that you will understand. Okay, so I'm assuming this point are somewhere going like this. Okay, don't go exactly with the value. Let's suppose this is going like this. So now we have the data points for those all square feet area which we have and for their price. So my question was, if suppose 627, so let's suppose this is 200 and this is here somewhere. Let us suppose 500, this is 700, this is 900, and this is, let's suppose, somewhere 1100 and this is 1200. Okay, so now my question is 627. So 627 will be somewhere, it will come here, right? 627 will come here. This is, so I want the value of 627 square feet, but we do not have any data points for the 627. Here we do not have. So now how would we get that? How would we get this square feet? So what the researcher said, is it possible is it possible that if we can create a line, create a line which is which will go closely to these all actual data points, which will go closely to this actual data points, and that line I will say this is the perfect line, or this is the good fit line for the prices of the given areas of houses. So if I will say that this line is a good fit, if suppose I will say this line is a good fit, means this line is describing well for all the prices of this given square feet, then definitely it can tell the best price for whatever the areas of square feet here 627 is there. So this one would be somewhere this value, whatever some value will be definitely here. So this value. So this is my predicted. But the question came that how would we come on the best line? This is the main question, that how would we come on this best line, that this is the best line. It could be this line, this line could be the best. Let me make it fresh here. This line could be the best, this line could be the best, this line could be the best, this is good, there could be the multiple lines. Now the question is how would we say which line is best, which is describing well. So can anyone just tell me which line is best? I just want you guys, anyone, to tell, whoever is new for this machine learning, because I know who knows this linear regression, there are people they can easily tell, and the reason also. But I want the answer from you guys, for those this is the first class and they are understanding at the first time the machine learning or the linear regression. Can anyone tell me which would be the best line? Yes, definitely. So biologically, visually, this line it could be this one which I draw first. So the line which is closest to the maximum points, from maximum actual points, that could be the best line. So here the question came, how would we count that? So to count those things, let's suppose here I'm building this one. So now I'm randomly taking a point. Okay, randomly I'm taking a point, and let me change the color. So let us suppose this is I'm saying I'm just for now I'm saying this is the best line. I'm saying, suppose, okay, now I want to understand, validate this is how it could be the best line. So for a value of, let's suppose this is the x1 value, this is the x2 value. Guys, if you have any question, just ask it. Okay, if you will miss anything, you will not able to understand. So x1, x2, x3, x4 and x5. Why I have written that? You just understand it's an area square feet of a house. Something, this is 200, 500, 700, 900, 1100 is there. Okay. And these are the some respective price. Like this is y1. This is here y2. This is here y3. This is y4. And this is y5. It means for the specific value of a square feet of an area of a house x1, this is the price y1 for x2 cases. Now I'm saying that this line is the best line. Now how would I decide whether it's the best or not? So what we'll do, I will try to calculate the difference from the actual data points to that. So see, for the point x1, for the point x1, my actual observation is y1. We have the data for the x1, we have the y1. Means let's suppose if I have a house given of 100 square feet, for that 5 lakh is already given. So this is the actual point for the 100. Yeah, for the 100 square feet house, 5 lakh is the price which is already given. But what my model is saying, what this line is saying, this line is saying definitely if this is my best line, so point would be somewhere here for the x1. So it is saying no, the best, our line is saying that it will be y2. So this is your actual point and this is your predicted. Predicted means the line, whatever the line is saying. Let's suppose I will come on that how this line is coming. So this is, I'm saying, this is your actual point, whatever in the table it was given, but our line is saying for the x1 this is my value. And the same way we will check for every value, like for the x2, x2, if suppose this is the y2, so this is somewhere difference, okay, some values are different. For x3 this is the actual value, but my line is saying this one. For x4 this is the actual value, but my line is saying this. For x5 this is the actual value, but this is. So how would we get that? We will calculate the difference. We will calculate the difference and then we can get an idea. Okay, then we will have an idea. So now from here, one thing, if you guys will try to understand, if I calculated the difference from my actual points and from the points which are on the line, I have to calculate the distance. Now if I will draw a line which has the minimum distance from all those actual points, those will be the good fit points. I mean, in the difference wise. So let me show you one graph. Uh, from there, you will easily relate that. Where it is, where it is. Let me show you. Somewhere it will come. Just, yeah, see, this one you can understand. If you'll see this, so these are, see that in green line it is saying actual response, means these are the actual points for a specific value of x, and this red are those points on the line. So these are the difference. These are the difference. So if suppose we have a 5 lines, 10 lines, 12 lines, so those lines, I will say that line, I will say is the best line which has this distance are minimum. Now again the problem is there. Sometimes what will happen, let us suppose this is the line. So here for this line this distance is lesser here, but in these scenarios somewhere it is higher. Okay, let us suppose this line here it is, okay, that's fine, but it is higher for here, it is higher for here. So how would you calculate the actual difference? So we will not go with the difference to calculate the difference of 1 points. We will calculate the average distance. Average distance. So this, in terms of machine learning or the AI, whatever this difference are there, no, we say that these as an error, that these are the error. Error means your difference between your actual point minus your predicted. So when I'm saying a predicted, that the points which are on the line for the specific value of x. So this is how you have to calculate. So this is the major thing, and now our main agenda is what? We have to decrease this distance. If the average distance, or I can say the average error, or it is also say the mean error, if in any case we will able to decrease that as minimum as possible, so I will say that line as the my good fit line or the best line. Are you guys aligned with me on this logic? Okay, so now we need to understand one equation of the line. So the equation of the straight line is y equals to mx plus c. This is the equation of a straight line. So when I'm saying it here, that let's suppose this is a line, this is the line, or this is the line. So whenever we will build a line, we need this two terminology, m, c and x3. So how it will be? Let's suppose. So this is one a random line I'm taking. Okay, this is the random line. So what is here m, what is here x, and what is here c? So this distance, if you are seeing this distance, no, this is C, and which is also called intercept. Intercept. This is C. And what is this M? I'll tell you. Let's suppose this X value is here 4, and here this X value is 5. Okay. Now let me change this color. Hmm. Hmm. So the slope, this M value, what exactly this M value says, let us suppose if this is the X axis and this is your Y axis. So let us suppose you are moving a unit distance. Unit distance means whatever the unit has given for this X axis, square feet, feet, meter, meter square, centimeter, whatever it is. Whenever you are moving on your X axis direction, or in any direction, you can say, to the from one unit, means from one point to another point, that's called in one unit. One unit, what difference you are seeing or what changes you have seen in the Y value. So you can see here for the point 4, let us assume y1 is the value for point 4. Now when I moved from 4 to 5, means 1 unit, when I moved here to this point, when I moved, now this value got changed with y2. So this you can see here, this angle. So the slope is, this actually says the dy, and here this is says the dx. So this change in y, dy means, just now do not understand as a differentiation or any mathematics, change in y and change in d. So this m is equal to change in y upon change in x. That is, and we also say it as a slope. Slope is this angle. Higher the angle, y will be higher, y will be more changes. You can see it here. So definitely, if this is the line like this, so see this angle will be higher. If the line will be like this angle will be lesser. Okay. So as much as this y will increase, definitely your m will, because you can say these two are the directly proportional. Directly proportional means if you are increasing something, this one is also increasing, and inversely means if your x will decrease, that in case of that will get increased. So that is how. So this is the slope. Now a line consists of these three values, and you can see we have this. Now we have the x value. We have already the house square feet in area. We have the intercept value now. Intercept value, and what is intercept value? I'll tell. Intercept is that value, the value at which your x is 0. So here, what is the value of x? X is 0. So when your x is 0, at that time, what is the value of y? And in this equation, if you will put on place of x, it is 0. So what it will become? It will become y equal to c. Means whatever the value of c is there, that will be the value of y. And you can see here, this is the value of x, which will be decreasing here. And here it will become 0. So at the 0, what is the value of y? This. So this is called intercept. Okay. So this is, I'm saying, the trigger point. This is, I'm saying, it will be the minimum price of that house. It will be. Let's suppose the 1 lakh. It is not going to decrease by that, I'm saying. So just for an starting. Because now understand, if my line will get changed, I'm saying this is my good fit line. So intercept will be something else. M will be get changed. So what is our agenda here now? We need to get the optimal value of M and the optimal value of C. Now, here I will write the final statement. How would I say which line is the best fit line? Which line is the best fit line? So, the line which the value of M and C on which we will have minimum error, means every that error which we discussed. This one, mean error, the value. So if you guys want, I'll take a separate class on which I'll go in more depth to make you guys more understand. Okay, but these are enough sufficient. So for what I have just started this um, class. So this is the your final line. So our agenda is to decrease the error, and on a decreased error, whatever the value I will get for M and C, that will be my final value, and that we have to deal. So now tell me guys, is there any confusion till here? If you have any question, you can ask. Sorry? No. See, now the calculating the this is the formula for the straight line. Now, how would you calculate the optimal value of M and C? So usually, what happens in machine learning linear regression, by default it will take C value as one. Okay, by default it will take C value as one. Okay, I'll show you. I'll show you in the implementation. C is the intercept. By default, it will take that value as a one. Okay, and then here the question is the M value. So the M value, you can understand it. We have the Y value, we have the C value, we have the X value. Can't we get the starting value of M? We'll get. Okay, that's just you need to equate. So now we have all, but the here question is the C value of 1 is the optimal value, or is that whatever value of M had came at the first time, is that the optimal value on which whatever the error had came, is that error is the minimum? This is the question. If it is minimum, then whatever the first time the value of M and C came, that's final. But if it is not minimum, then it will iterate again, and it will the process will keep on going until or unless we will not get this value minimum. And how actually that algorithm work, for that I will take in class, and I'll explain you that algorithm which is called gradient descent. Okay, that algorithm is called gradient descent, to achieve the optimal value of M and C, to make the error minimum. Okay, so this is how the gradient descent, how it works, and I'll explain it. That will go a little bit more mathematical, but at least if you do not understand much mathematical, you need to have the intuitions that how exactly the gradient descent works. That will be much more enough. Okay, so now we understood y equal to mx plus c. So in linear regression, there are two types. The first is simple linear regression, and the another is multiple linear regression. Now, what does it mean by simple linear regression? Means if your price is depending on only one feature is means area of your house. But in real time scenario, is that the only factor on which the price of a house is getting dependent? No, it depends on the how BHK is 2 BHK, 1 BHK, 3 BHK, 4 BHK, whether it's a villa or not, whether it's a how it is society is a covered campus, or in which locality it is, whether the parking is there or not, so on which floor it is. So these are the multiple factors on which it depends. So now here in case only one column, but in case of multiple, now your equation will change like this: m1x1, m2x2, m3x3, plus so on here mn xn plus c. So this is called your multiple linear regression. So you will ask, so for two columns we build like that. So how would we build for this? So it is not like that. Something you need to intuit, something you need to understand. So this all will go like this. This all will be formed like this. This is one is your here a target, which is your price, and these all are your column: x1, x2, x3, x4, x5, x6, x7. Okay, on basis of that we will see. And these are the, so the slope, what exactly the slope means? Now let's understand the meaning of a slope in more better way. So if I'm writing here y equal to 3x and here I'm writing y equal to 4x. So if here I will change the x value of x is 2 and here also I will change 2. So what will the value of y here? Here the value of y will be 8 but here the value of y is 6. So what does that mean? So from that we can conclude that here the value of x is affecting more the y. I mean in this case, sorry, the value of x is affecting more to the y. But in this case, the same value of x, it is affecting less to the y. Because by changing a value of 2 in a both scenario, here y become 8, but here y become only 6. Means this is changing more to the y, affecting more to the y. And why? Because of the slope. Means higher the slope, more important that feature is. Means if suppose you are doing an house price prediction and in that area is there, locality is there, bathroom is there, balcony is there, uh, BHK is there, whether it's a 2 BHK, 3 BHK. So this is there. Okay. So it's not like that. No, those all features are equally dependent on the price. There must be something like that. That area is going to impact much on the price. Then after the locality might impact much on the price. Then after the BHK is going to impact much on the price. Then after the parking space is going to impact much on the price. So, and how it will come? It will come, you will understand it by seeing the M value. So the for the feature for which the M value, the slope is higher, by that we will understand that feature is most important and that feature is more important for the price. So means by changing that feature, our price is going to change much. Okay? No confusion in this? Okay. So now here we need to understand two things. The first, I said it, in machine learning there are a lot many algorithms are there. So we need to understand when to apply which algorithm. So for that we need to understand the data first. So data, in that you need to see, this is the hierarchy we need to always follow for any, to solve any kind of machine learning problem. We need to see the target column. The target column means what you have to predict or what you have to get the value for which column. So now if target column is categorical, or you can say discrete, or it is a continuous. Now let me give you an example which are the categorical data type and which are the continuous. So on a simple manner, understand the numerical values are the continuous and the countables. Let's suppose something, if you have to predict whether someone will pass in exam or fail, pass or fail, like this kind of. If you have to predict the grades of an any student data, like first grade, second grade, third grade, so these all are the countable. Means if you have a countable value in which the in your entire millions of data or the thousands of the data you can count uh, the target. Okay. And the continuous, let's suppose if you have to predict the price is not countable. It could be the 100 rupees, 100.5 rupees, like that. Profit, loss, those are all within the decimal, it can be, those are non-countable. Like height, these kinds of things. So you can understand now, you might can relate. So if your target is continuous, there we need to apply the regression based model. There we need to apply the regression based algorithms. And where it is categorical or discrete, there we need to apply classification based classification classification based algorithms. And now by the name it is clear, linear regression, I'm saying linear regression. So we can definitely understand, for a house price prediction we need to apply the linear regression model. Okay. Now let us suppose our target would have like that. We need to predict the locality, that whether it is in, let's suppose, locality means, or let's suppose the city, let whether the specific house is from the Bangalore, Pune, Hyderabad, Delhi, somewhere like that. So that could be the categorical. So for that categorical, we need to apply the classification kind of algorithm. So for that, there are, in regression also there are multiple. So in the same way in classification. So for this, now let's write it here, logistic. So I'm not writing, actually it wrote here regression also, but I'm just, let me not write this, otherwise right now you guys will get confused. Something called decision tree. Okay, so this is the algorithm for a classification, and this is for the regression. So now at least you guys will understand, no, by seeing at the use case, that what I have to do if suppose you will get the data. So what you have to do with that data. So once you will evaluate your use case, that what I have to achieve, then after you will understand that which algorithm I have to apply on that, whether it on regression or the classification. In that I don't think there would be any issues, right? Okay, so now let's jump to the implementation. Today we will do implementation, and I'll show how to create the model, train the understand the use case and train. And I will share one data with you guys, and I will request you guys to solve it by your own. Okay, and just let me know if you will face any issues in that. Okay, so here just I'm taking very basic data. Okay, to make you guys understand. Just allow me a minute. One second. One second. I'm sharing my screen. Just some minute. Okay. Okay. You can see my screen, right? See. So here, what I'm trying to do now, here, these are some important libraries first we need to import. Okay. So this is a Python implementation which we are doing, and this is a Jupyter notebook, one of the IDE which are mostly used in data science field. But this is not the only one. Apart from that, you can use PyCharm or VS Code, Visual Studio, sorry, you can use. So these are the library which are required for our use case, and I will explain one by one to each. So here, see this NumPy, why we need if we required any mathematical kind of operation like multiplication, array, if we have to multiply those things. This matplotlib, if we need to visualize something for that. And now, what is this trend test split? I will come on that. This is here for the linear regression. Okay, linear regression, which the model which you saw. The first we need to import that, and you can see here. I said that mean squared error. We need to understand that why mean squared error. We need to decrease that. And this is Seaborn again here. This is for the visualizations to plot the graphs. Okay, and sklearn is a library in which there are a lot many machine learning models are there, algorithms, and some data sets also available. So from the sklearn, actually I'm trying to import, there is one data set which is called California housing data set. Okay, so I'm just importing from the sklearn.dataset. I'm importing this object, and you can see it here. uh, if I will run, see, DESCR housing dot DESCR means describe. So whatever this data set, I'm taking the description. So what this data set characteristics are, it is saying number of instances 20,640 records are available in that data, and it is saying number of attributes 8 columns are numeric, and the predictive attributes and the target. So the 8 numbers are the columns in, and then after there is one target column, and these are the attribute information, means this is the column names: mid inc, house age, average room. So mid inc means median income in block group. House age means median house age in that block. So for this is for the specific block house. data it is. So median age means how older that house is. So median is the center point. So I will come on that the statistical part. You just understand this is the age of that house, how older that house is. Average rooms per household, how many average rooms are there, and the same the bedrooms are there. Block group population, in one block how much population is there, and this is the latitude longitude, the location of that specific house. Okay, this is the description. So here it is written the target variable is the median house value of California district. Okay, expressed in hundred of $1,000. So you can see it here. I There is an one library in Python which is named as pandas. If you can see it here, I have imported somewhere, or maybe it has got deleted. Let me. So that pandas and as PD means this is the alias name. In spite of using this big name, we are giving this alias name as PD to use it handy. So PD.data frame. There is one function in pandas which named as a data frame, which convert your data into a structured manner, in a tabular manner. See that. And head means it will show you the top 5 records. See, it has shown us all these 8 records and their columns. And the target columns now, as I said, you have to divide your column in X and Y. So X are those columns by that. So we need to predict the price. So you can see on a target is our price here. See, from the housing, from this housing, if I will just show you, if I'll show you here, see that dot target. See that this is all the price. If you want to see the target name, if I'll do that, you can see this mid house value, median house value, that is okay. So you can see here that target I am putting in the y-axis, and all the columns, these all columns I'm putting into the x-axis. Now here let's understand what is this train and test splitter there. So let us suppose you have this data. Let us suppose this, you have this data. Okay, now what is the best practice to do? We need to split the data into two parts. One is called train and another is called test. The question is why we do that. I'll come and I'll let you, you will understand it. Let me explain this at till the end. So usually what we do from the entire data, we take 70% or 80% of the data as the training, and on testing 30% or 20%. So if I'll go more specific to make you understand, if this is the data of having 100 rows and 4 columns, so the 70% of the 100 is what? 70. So the 70 rows and the 4 column will become the train, and the 30 row and 4 column will become the test. There will be no split in the column. Split will be in the records. So always remember, okay? And if suppose it is 80%, so 80 rows, 4 column will become the train, and the 20 rows and the 4 column will become the test. So this is how I do. Now let's suppose here the data is 104 and assume that we are going 70-30. So here it will become 70 and the 4, and this record will be 30 and 4, the test data. 30 is the row, 4 is the column, 70 is the row, 4 is the column. Now why are we doing and saying it as a train and test? So on this data, we will train our machine learning algorithm. So why we do, let's understand a real time from a real time scenario. Let us suppose someone is trying to learn the driving, and they learn the driving on a ground, in a ground. And now if I want to test their driving skill, if I will again ask him to drive on the ground, definitely that guy or that person will drive well on that ground. That doesn't mean that guy has the good skill of the driving. If I actually need to check their driving skills, whether it is good or not, I will ask that person to drive on there or drive on that places or those areas where he or she has never practiced. And in that area, if he or she dropped well, then I will say now that person is has having the good driving skills. So this is the same logic we are using. We will use this data to train our algorithm to get the optimal value of slope and the intercept on which the error is minimum. Now I will not ask my model to perform same on this record, and now I will give this record to my machine learning model and I will ask now you have to predict. And if it predicts well, then I will say this my model is good. So how the prediction will go, let us suppose this is data, some values are there. So the target is our price, and here this is I'm writing x1, x2, x3 and x4. You will understand this is an house price, square feet, something is bathroom, bhk, parking, balcony, like those kinds of thing. So this is the train data. So in train data also, first it is trained entirely, and this is here my test data. Understand this very carefully. This, if you will understand, you will understand the code also. Again here x1, x2, x3, sorry, x4, this is x3 and this is price. Now this part is called x train, because I told you, no, we need to divide into x and y, and though it is a train data, so I will say it's an x train, and this column I will treat as an y train, because these are the independent and these are the dependent. So I said the dependent will be go on the y, independent will be on the x. So these are from the train, so that's why x train, y train. And this is here, this is the test data. So that's why I will tell this is as a x test, and this is the price. So I will tell this is as a y test. Now, I will train my algorithm. Let's suppose this is my linear regression. I'm writing as an LR, and I'm training it on the x train and y train. I am training it on that. Now my model has trained. So how my model has trained? It has got all this value of always x1, x2, x3 and understood this would be the price. Again, this will be the value. Every time one record will go, and every time the value of M and the value of C will get changed. So this is how go, and it will learn. Here it is training means learning. It is trying to learn all those value from the, if the input values are that, then what would be the price. Now for this model, I will say I will ask my model to predict. Now you have to predict, and what I will do, I will give x test only this value x1, x2, x3, x4. I will give this value only, and then I will ask my model, now you have to predict the y test. So this my model will predict the y test. So I'm giving the name as y pred. So now you understand, you have already a actual value of y test, and now your model has predicted a y predict. If I will take the difference of between these two, this my actual and the predicted, I will get the error. And if that error is also less, same as that training, then I will say my model is now a skilled model. Now my model is a good model, which is working well on the new data as well. Because here I was training the model, and here I was not training. Here I was just asking the model by giving the x input values of the descriptions of the house, and then I'm asking now you predict the value of that. So if my model is predicting, and for that we have already a value, so if it will predict this y predict and actual values are y test, so I will check difference. I will subtract this one from this one or this one from this one, and I will have the error. If this error is as minimum as the training error, so I will say my model is performing well. Is that clear till here? Okay. So now let's see. So if you can see here on x-axis and y-axis. So here uh, I had given the in a train test split function, you have to give your x and y, and here I'll come on the random state test size. So what I said, no, whether it is taking 20% or 30%. So if you pass here the 20%, automatically this one will take. So here let's understand the shape of df dot shape. So it is 20,640. Okay. Now I'm saying here test size is 0.2. So means the train will be have the 80%. So if you do the 80% of 20,640, it will become it will come 16,512. Okay. 1 second, let me plug in the charger. Just give me a minute. Yeah. So if you can see it here, and what is random state? Random state means every time if I will learn, no, what it is actually doing, it will take the random 80% or the 20%. So if every time I will learn, it will take the different code. But if I'll put a random state 1, 2, 3, or any value of in random state, the same value will records will take it every time. So I do not want the error should get difference with some value. That's why I have taken it. So this is I'm checking. Now here and here I'm just importing the model OLS and GLM. What is this GLM? I will come this on the later. OLS is ordinal least square. Now let's see it here. So in that OLS, I'm passing here Y train, our Y train. So for the X train, our all the X value features of the house, and the Y train is that for that value, whatever the price. Again, the X test is the rest 20%. X values means features of the house, and that 20% for that X test, these are the price values. Okay. Now I'm training it here. So first you need to pass always Y train in the OLS and then your X train. But what I'm doing here, sm.add constant. So let's see what exactly sm.add constant will do. So first, let me show you the X train. X train is looking like this. This is all your X train simple data. And now if I'll do sm.add constant, see that what it will do. See, I said no, by default, it will take the constant value as 1. That C value by default, and this one will get change. I'll show you this one will get change also. Okay. Now here when I will run this is here, it will the model object, and model dot fit means it will start training, it will start learning those. So you can see it here, it had learned in a minute, in a second. And here I'm checking the summary. So summary means we need to focus majorly on these two parts. So I will tell you tomorrow what exactly this is. Okay. So this at R square and the adjusted R square, and AIC BICs are also important, but this is later on we'll say these are the more advanced. We have to see. But R square and adjusted R square you need to understand that. I will take it tomorrow. So you can see it here. This model has taken all the columns. So what is this p value? On that again I will come what exactly this p value. That's right now it is not important. Now I'll just only today tell that if you train a model and how you can save the model, so that tomorrow I'll go a little bit more depth, some important terminologies, and tomorrow I will show the deployment as well in a local, that how I can deploy that. Okay, to use that as an application. Now you can see here there is one library which is called pickle. So in that now I will save my model. This is my model object that I will save. So you can see here with open in the Python there is a way you can create a file. So wb is a write binary, means it will create a dummy binary file, and in that dummy binary file you can see it here pickle.dump. I am writing my model object in that. So if I will run it here and I'll show you, if you guys will see that here a second ago this model has saved of the and memory size is 3.97 MB. Okay. And then if we want to load this model, we can again with open this model name or the path. If suppose you are not in the current directory or of model directory, then you have to give the entire path, and rb means read the binary file, and then pickle.load that file name, it will load that. Okay. And if I will show you here this loaded model, and so it is again a see that stats model regression linked. So this is how we build the model, train it, we saved it, and we load that. Now how would we use it tomorrow? I'll go and I'll tell you. But in meanwhile I'll share this notebook and the video with you guys. And one more video I'll share with you, some other guy video. You can go through that even, try to understand. If not, tomorrow again I will add some functionality and I'll tell you that what is r square, adjusted r square. And the daily basis we will move ahead with the theoretical part and the hands-on both. So you can just go through with this Jupyter notebook. I will upload in the GitHub, and I'll share the link. Okay, is there any question in that? Now tell me. So in 155, what is OLS is ordinal least square. This is the model function, that linear regression function which we were talking it. And I said no, first we will try to train that algorithm. So for training, we need to pass your input and your output. So this is my output y train and this is my input. Input means X train. X train is what? This is all your house description data. But with that, we need to pass the intercept. Then only it can build y equal to mx plus c, that equation. Okay. That's why we are passing here sm dot add constant x train. And then this model object has created. And in that model, now I'm fitting. Fitting means now training. Here I am training my finally model. And the model name is LR underscore linear regression underscore model. You can give any name to it. Okay. And here I'm just checking the summary, means how this summary actually explain the lot many things about the features, that r square, adjusted r square, f statistics, the p value, the coefficient, standard error. These are the confidence intervals. So those all things are a little bit more in depth, which we will see it slowly, that how we can extract the information from this. So this means that you are just training your model. So now I will share this GitHub link, this code with you guys, and I'll share one data path as well, and try to use that data within this code, and let's see that what result you guys are getting it. Okay, then it will be more clearer to you. Understood? Okay.